Ever wonder what makes your smart devices so, well, smart?
Yeah, it's like magic, right. But it's not magic, it's embedded software engineering.
That's right. Today we're diving deep into this world where software meets hardware.
And we have a true expert to guide us.
We've got Ayub Shaikh from Holistica Consulting.
24 years in the field, he knows his stuff.
So if you're thinking about a career in this area, or maybe you're hiring for this role,
This deep dive is for you.
let's find out. What does it really take to excel as an embedded software engineer?
What skills are we talking about? What kind of tools?
Yeah, let's break it down.
One thing Ayub stressed is that it's all about bridging those two worlds, software and hardware.
Right, making sure they play nice together.
Exactly. It's about creating that seamless interaction we see in, well, everything.
Like my coffee maker? I mean, that thing practically makes a latte on its own.
Exactly. But you see, embedded systems are often designed for very specific tasks.
Like brewing the perfect cup of coffee.
Right. And they often have limited resources, which makes it even more challenging.
So where do you even start if you're interested in this field?
Well, first things first, you gotta know your C and C++L.
The programming languages, right?
Yeah, but Ayub really emphasized that it's not just about knowing the basics.
So it's not just about writing nice-looking code.
It's about understanding how your code impacts the hardware directly.
Interesting. So, like, memory allocation, working with hardware registers.
Exactly. It's about squeezing every ounce of performance from those tiny devices.
I'm starting to see why experience is so important in this field.
For sure. And then, of course, there's the world of real-time operating systems, or RTOS.
Now, those sound pretty intense.
They are. These systems manage the timing and scheduling of tasks super precisely.
Think of something like an airbag in a car.
That's a great example. The software needs to react in milliseconds, no room for error.
Wow, that's high stakes. And what about those tiny little brains behind it all, the microcontrollers?
You got it. Knowing those little guys inside and out is key.
Programming them, understanding their architecture, all that good stuff.
Right, they're like the heart of any embedded system.
We've got the programming languages, the operating systems, the hardware itself. Feeling a bit overwhelmed already.
Don't worry. There are tools to help you manage all this complexity.
Thank goodness for that. Like what kind of tools?
Well, you've got your embedded IDEs, like Heal and IRR.
For writing and debugging code, I assume.
Yep. And then there's version control, like Git, especially for those big team projects.
Keeps everyone on the same page.
And of course, debugging tools like JTAG and IC.
Those sound pretty serious.
They are. You need those to really see what's happening at that low level.
I bet debugging in embedded systems is a whole other beast.
Oh, absolutely. You're tracing signals, checking memory locations. It's like detective work.
But finding that solution, it must feel pretty rewarding.
Oh yeah, when you finally crack the code and everything works perfectly, there's nothing like it.
Okay, so beyond these core skills and tools, what else should an embedded software engineer know?
Hardware architectures. Knowing how processors, memory, and peripherals all talk to each other.
Makes sense. And what about those communication protocols I hear so much about?
Right, like I2C, SPI, UART. They're like the languages devices use to communicate.
So they can all understand each other.
And don't forget about power and memory management.
Super important, especially for battery-powered devices, right?
Exactly. You got to make that code as efficient as possible.
So efficiency is key in this field.
Absolutely. And that's what Ayub really looks for when he's interviewing candidates.
Speaking of interviews, what kind of questions can really separate the pros from the amateurs?
Oh, Ayub had some great ones. He likes to ask about memory optimization, like how to reduce a function's memory footprint.
That's getting pretty specific.
Yeah, it really shows if they understand those embedded system constraints.
And how about debugging those tricky hardware issues?
Oh, he'll definitely dig into that too. Like, what would you do if a sensor starts acting up?
I can see how that would reveal a lot about their problem-solving skills.
Exactly. He wants to see that practical experience shine through.
So, any final words of wisdom for those aspiring embedded software engineers out there?
Ayub emphasized that it's not just about technical skills, it's about understanding the hardware too.
That bridge between the two is what makes a great engineer.
Exactly. And don't be afraid to get your hands dirty, experiment, build your own projects. That's where the magic happens.
Love that advice. So, as we wrap up this deep dive, we have a question for you.
What advancements in embedded systems have caught your eye lately?
What do you think is really pushing the boundaries of this field?
And why is it significant?
We encourage you to explore these topics further.
See where your curiosity takes you.
Thanks for joining us.
See you next time.
Bye.